Chapter 15, number 26. The patient in the figure is to receive an intravenous injection of medication. In order to work properly, the pressure to fluid containing the medication must be at 109 kilopascals at the injection point. If the fluid has a density of 20 kilograms per meter cubed, find the height at which the bag must be suspended above the patient, and assume the pressure inside the bag is 1 atmosphere. And then if a less dense fluid is used instead, must the height of the suspension be increased or decreased? So again, we're going to say that we have basically some pressure here and some other pressure here. And we know that pressure 2 plus rho GH gives me pressure 1. And so we can say that, solving all of this over, H is pressure 1 minus pressure 2 all over rho G. And we just get some numbers. So we can say, well, that's going to equal the pressure at the injection point must be 109 kilopascals. The pressure in the bag is given as 1 atmosphere, which is 101 kilopascals. And then we're told the fluid has 1020 kilograms per meter cubed density. Times the value of G, which of course is 9.81 meters per second square. Well, let's walk through and see what comes out. We get what seems to be a disturbingly small number, 7.995 times 10 to the minus 4. But we have to be careful because our units here are going to be kilopascals over, well, kilogram times meter per second squared was newtons per meter cubed. So just talking about the units, kPa over newtons times meter cubed, but kPa over newtons, the newton is the same as kilonewtons over newtons times over newtons meter square over newtons times meters cubed. And so we get something like that this unit here is really kilometers. So it's probably true, but it certainly isn't very useful. Instead, I want to say that there is 1,000 meters per kilometer, so I want to take my answer and multiply by 1,000, and I get 7,995 meters, which according to our sig figs of 3, only 3 sig figs, is 0.800 meters. Obviously, it probably would have been smarter to just change kilopascals to pascals at the very start. But here we are. Also, Walker only gives it to 1 decimal place, but we do have 3 sig figs, so we really should do that. And then part B, if we use a less dense fluid, well, we can see that if we use a less dense fluid, since the density is on the bottom, we make this number smaller, we'll make this number larger. So part B says if the density is less, then the height has to become more.